Hello students! In this short video, we'll be adding to the SOL G.9 with a quick study on rhombuses. Let's take a look at the example on the left. It says in rhombus ABCD, DB is equal to 16 and AC is equal to 12. What is the perimeter of the rhombus ABCD? This one's really tough to do without a picture, so I'm going to give myself a sketch. Rhombuses are quadrilaterals that are parallelograms where all four sides are congruent. It says to name this rhombus ABCD. A, B, C, D. It also gives me the information about the diagonals. From D to B is 16, from A to C is 12. So obviously the diagonals are not congruent to each other. In fact, I'm not really sure about where I want to write that 16 and 12 so that it represents the entire line. I want to add something in here, something I know about parallelograms. I know that in all parallelograms, this point in the middle is a midpoint. And if this is a midpoint, then it cuts the diagonals in half. So instead of writing DB is equal to 16, if I cut 16 in half, I'd have 8 and 8. And instead of writing AC equal to 12, I can cut that in half and have 6 and 6. Well, how does that help me? The question is, what's the perimeter of the rhombus? So we're talking about the distance around these four outer sides. Well, I know something else about a rhombus that's important. I know that a rhombus's diagonals are perpendicular. So all four of these angles in the interior of the rhombus are 90 degrees. Well, what does that mean? That means I have a right triangle in this picture. And what is important about a right triangle? Well, if I know two sides of a right triangle and I'm trying to find the third side, I can yet again use the Pythagorean theorem. A squared plus B squared equals C squared. I've put an X along the hypotenuse of this right triangle because that would help me find the perimeter. 6 is going to take the place of A, the short side. 8 is going to take the place of B, the medium side, and I'll solve for X. 6 times 6 is 36. 8 squared, 8 times 8 is 64. 36 and 64 make 100. To remove the square on the X, I need to use its inverse, which is a square root. And the square root of 100 is 10. So that means this outer piece from A to B is equal to 10. Well, don't forget that you're working on a rhombus, which means all four sides are congruent to each other. So while AB is equal to 10, so are the other three sides of the rhombus. Each side is equal to 10. And if we're finding the perimeter of this rhombus, and now we know that each side is equal to 10, the perimeter is going to be 10 plus 10 plus 10 plus 10, which is 40. That's a great rhombus question. It uses the diagonals, it throws in some Pythagorean theorem, it brings you back to make sure you remember you're working on a rhombus where all the exterior sides are congruent to each other. That problem has it all. Since we worked on the sides here, this next example is all about angles. It says, find the measure of all missing angles of this parallelogram. Well, more specific than it just being a parallelogram is that this is a rhombus. It's in the rhombus section. So right away, I know all 4 exterior sides are congruent. I also know that all 4 interior angles are congruent, so they're all 90 degrees. I also know that a rhombus is part of the parallelogram family. So that means these sides are parallel, and it means that these diagonals are transversals of parallel sides. And if they are transversals of parallel sides, then I've got some alternate interior angles to work on here. Okay. What I also know is that the point E is a midpoint, and if it's a midpoint, it cuts the diagonals in half. So each diagonal has been sliced in half. Well, what do we have here now? How is this helping me? Well, what's happening is that now I can really look at this as 4 triangles, and I know that all 4 of these triangles are congruent to one another by S, S, S. The 3 sides of each triangle are congruent to the 3 sides of all the triangles in this picture. So that 36 degrees on the right side of this blue transversal can be reflected to the upper side of this blue transversal. And the 36 degrees on the angle D can be reflected below as well. That makes that diagonal an angle bisector. It's cutting the angle in half. Now I just need to find the 3rd angle in each of these triangles. In each triangle, we've used 90 degrees and 36 degrees. We know that triangles add up to 180 degrees. So if we subtract away the 2 angles that were given, we'll find our 3rd angle. 180 minus 90 minus 36 leaves me with 54 degrees. And this 54 degrees is for each of the angles that's left over, because all 4 triangles are congruent to each other. Well, I think that shows us that we really have 2 lines of symmetry in this figure. We slice our rhombus down this diagonal. Everything on the top can flip over to match everything on the bottom. 2 diagonals, 2 lines of symmetry. Okay, now we just have to find each of these angles and write in our final value. Let's start with the top. A to B to E. A to B cut down to E gives us a 36 degree angle. A to D to E. A to D to E is another 36 degree angle. E, D, C. Trace it out if you need to. E to D to C is outlining another 36 degree angle. Next is A to E to D. That's hitting at the midpoint in the middle. That's a 90 degree angle. In fact, all the angles with a vertex of E are 90 degree angles. E in the middle here represents the vertex, and all of those are 90 degree angles. Next we have E up to A, out to B. E, A, B, 54 degrees. Next is E, A, D. the left half of that angle, another 54 degrees. Then we have E down to C to D, also outlining a 54-degree angle. And finally, E to C to B, another 54-degree angle. Look at all the repetition here. Including the 36-degree angle that was given to us, we have 4 36-degree angles, 4 90-degree angles, and 4 54-degree angles. You guys, I can't stress that enough. That is because we have 4 congruent triangles in this shape. These diagonals are lines of symmetry. They're angle bisectors. They're perpendicular to one another. Lots of work here on this rhombus. Thanks for watching. Hope this was helpful. Our next video will be about trapezoids.